Hey, did you hear about that catastrophic bridge collapse last year? It was a devastating incident that claimed numerous lives and caused immense property damage.
Yes, I remember reading about it. It was a tragic event, but what caused such a massive failure?
Well, according to the investigation, the primary cause was a critical flaw in the steel girders that went undetected during construction. If only they had performed proper non-destructive testing, NDT, that disaster could have been averted.
Non-destructive testing. I'm not familiar with that term. What exactly does it entail?
NDT is a group of techniques used to evaluate the properties and detect potential flaws or defect in materials without causing any damage to them. It's crucial in ensuring the integrity and safety of structures, machinery, and components, especially in critical applications like bridges, pipelines, and aircraft.
I see. That sounds incredibly important. How does it work, and what are some common NDT methods?
There are various NDT methods, each suited for different materials and applications. For instance, ultrasonic testing uses high-frequency sound waves to detect internal flaws, while magnetic particle inspection can reveal surface and near-surface defect in ferromagnetic materials.
That's fascinating. Are there any other widely used NDT techniques?
Absolutely. Radiographic testing, which uses X-rays or gamma rays, is particularly useful for detecting internal flaws in dense materials like metals and concrete. Visual inspection, although basic, is also an essential NDT method for identifying surface defect or irregularities.
It's incredible how these techniques can uncover hidden flaws that could potentially lead to catastrophic failures.
Precisely. NDT is an indispensable tool in ensuring the safety and reliability of structures and components. In fact, many industries, including aerospace, oil and gas, and manufacturing, have strict NDT regulations and standards to adhere to.